Services in Angular. Services in Angular are simply TypeScript classes with the injectable decorator. This decorator tells Angular that the class is a service and can be injected into components that need that service. We use a service to share logic or data across components. We use a service to encapsulate external interactions like data access. We can reuse the service at many places. Create a service by decorating a class using @injectable decorator. As we see here, we have created this my service and we have decorated this class using this injectable decorator. The next is provide a service using providers array of module or components. As we see here, we have provided this newly created service using this providers array. And the third is inject service in a component constructor. So as we see here, we have written one constructor for a component and we have injected this service as we see here. Okay, so the next is providers versus view providers. Providers and view providers makes differences when we use ng content in our components template. If we want to inject any provider into projected content, we have to use providers. If we want to inject any provider in a components view, we can use providers or view providers both. View providers cannot injected into the projected content. View providers allows you to prevent projected content from messing with your services. As we see here, we have written providers and view providers syntax. First is the providers array and we are passing our service, and the second is view providers array and we are passing my view service here. Okay, so the next is redirecting ways in Angular. Actually, we can follow two approaches to redirecting in Angular. One is a router link directive in a template and the second is navigate method of a router service in our component class. So the syntax for router link, as we see here, we have added one router link directive and the value for that router link directive is a array and we are passing the actual route where we want to navigate the page. And the second is we'll inject this router service in our component class and we can use this dot router dot navigate method and we are passing one array which is having our URL. In this way we can redirect in an Angular application. Okay, so the next is how to share data between Angular components. So there are 4 ways to share data between Angular components. As we see here, first is parent to child via input decorator. The next is child to parent via output decorator and event emitter object. The third is child to parent via view child decorator, and for unrelated components we can use services. Okay, so we'll see how to send the data to a child from parent using this input decorator. As we see here, we'll write code. As we see here in a parent template, we will pass the name property using these square brackets. So this is the way to bind the data to a component, and in a child component we'll use input decorator to access that name property. And the second is send data to a parent from a child via output decorator and the event emitter object. So in a parent template we'll write a component as we see here, and we'll bind the on name update event to that component. And in a child component, uh, we have written this on name update method, and we have decorated it using our output decorator and we are assigning value to event new event emitter as an event emitter object. And the next is when we want to send some data to a parent, we'll use this emit method of output decorator property as we see here. Okay, so the next is we can read some data from child in our parent component via view child decorator. As we see here, we'll render our child component in our parent template, and in our child component we have written this name property, which is a public, as we are reading some data outside of this child component. Then the next is in our parent component we are getting the reference to our child component using this view child decorator. As we see here, we have written this view child decorator syntax here, and we are getting that reference in our child variable. And in ng after view init method lifecycle hook will read this name using our this child reference to our child component. As we see here, this dot child name equal to this dot child dot name. So child is our child component which we have referenced using view child decorator. And the last one is we can communicate between components which are unrelated component. We can communicate using services. So if there is no relation between components, we can use services to share data between them. We have already seen how to use services in Angular. So the next is ng template, ng container, and ng content. These three directives in Angular serves different purposes. We will see how to use this ng template, ng container, and ng content. So the ng template helps to create dynamic templates that can be customized. These template elements only work in presence of structural directives, which help us to define a template that doesn't render anything by itself but conditionally renders them to the DOM. So here we can see the example. We have written this ng template element here, and we are referencing it using this show ng template content, and we are rendering it conditionally as we see here. So that depends on condition. If the condition is a true, this template will be rendered, else this template which is written here will be rendered. So this only works in presence of these structural directives as we see here. Well, the next is the ng container. So the ng container is a directive that allows you to group elements and it doesn't render in a DOM. In Angular, we can use only one structural directive at a time on a single element. We cannot use multiple structural directives on a single element. So in this case, we can use ng container, and as we seen, ng container doesn't render in a DOM. So as we see here, we have written these two structural directives as we want to check the condition also, and uh, loop through the items also. So we have written this ng if and ng for on a single element, but this doesn't work in Angular. So to solve this issue, we can make some changes like this. We can use one parent div and we'll use the ng if for that parent element, and in inner element we can loop through the list. But the problem here is this extra div will going to render in our DOM. So to solution for this is this ng containers. Ng container doesn't render in DOM, but we can use this structural directive on ng container, and then inside that we can write our actual div to loop through the list. So this will solve our issue. And the next is a ng content. We have already seen it in detail about the ng content. So the ng content is used to project the content into components by the host element. Ng content tag we can use as a placeholder for that dynamic content. As we see here, we are rendering one div in app child component. Okay, so the next is we are going to see how to create embedded view using create embedded view method. So we can create an embedded view using create embedded view method and then attach that view to the DOM via view container reference. So as we see here in a template, we have written one template and we have written one ng container directive. So the template will have one div which is going to print name from our context, and we have added the reference variables for our ng template and the ng container template and the VC respectively. And so what we are going to do is we are taking this template, creating the embedded view, and then we are going to insert that embedded view in our ng container. So in our component, as we see here, we have taken the references of template and the container, and we are storing it in this template variable and the VC variable. So and the next is we are reading this template as a template ref injector, and we are reading the ng container as a view container reference. So the next step is in our ng after view checked method, we are creating embedded view using this template reference injector. So as we see here, this dot template dot create embedded view, and for that create embedded view method we are passing a context object for this name variable, and as we see here we have passed this from context property, and we are reading that from context property as a name in our template. And once we create this embedded view using create embedded view method, we are next step is the inserting that embedded view in our view container reference as we see here. So the next is schemas property in an ng module. So sometimes we have seen that Angular throws error like this is not a known element when we use any external element in our Angular application. So this schema property will allow any non-Angular elements and properties in our Angular application. Angular won't throw an error like this is not a known element if we are using any non-angular element. So to allow the non-angular element in our angular project, we use this schemas property, and the schemas property takes an array as a value, and in that array we pass this token custom underscore elements underscore schema, or no underscore errors underscore schema. So these two are the allowed values for schemas property in ng module. So in this way we can allow the non-angular elements in our angular application. Okay, so the next is ng style and ng class. So these are the directives in angular. So the ng style directive lets you set the style property to a DOM element using JavaScript object, and the ng class directive also allows you to set CSS class dynamically for a DOM element using JavaScript object. So in case of ng class, we pass an object, but the property values of the object could be true or false. So if the property value is true, that property will attach as a class to the DOM element. If the property is false, that property won't attach as a class in a DOM element. As we see here, we have written ng style and ng class directive, and the values are just plain JavaScript objects, as you see here. So the next is a DOM sanitizer. So DOM sanitizer helps preventing cross-site scripting security bugs, that is XSS bugs, by sanitizing values to be safe to use in the different DOM context. Angular has a dedicated class DOM sanitizer to sanitize trusted data. By calling any of bypass security trust APIs, it disables Angular's built-in sanitization. These bypass security trust APIs carefully checks and audit all values and code paths. So the DOM sanitizer class provides actually 6 APIs which takes string value as an argument. So these are the 5 APIs of the bypass security trust. First is for HTML, then for style, then for script, then for URL, and the last one is the resource URL. So these methods takes a string value as an argument, and it returns the safe HTML, safe style, safe script, safe URL, safe resource URL values for the user, as we see here. There is one another API which is provided by DOM sanitizer, which takes context and the string value and return the safe value for a user. So the different contexts are like HTML, style, script, URL, resource URLs. Okay, so the next is inner HTML property. Rendering HTML typically has the potential to introduce cross-site scripting bugs. To render HTML, the rendered HTML could contain malicious scripts that present a security issue. So behind the scenes, inner HTML property uses Angular's DOM sanitizers, which uses a list of approved HTML elements and attributes. So this will restrict your inner HTML values from using script and style tags as well as the style attributes. So the next is the routing strategies in Angular. So the Angular supports two different location strategy or routing strategies. One is a path location strategy and the other one is a hash location strategy. So the hash location strategy uses the hash style routing, where the URL looks like it includes the hash in between. And while the path location strategy uses HTML5 routing, so the URLs are, as we see here, the clean URLs for product route. We should use path location strategy because it produces clean and SEO friendly URLs that are easier for users to understand and remember. Also, we can take advantage of server side rendering. But Angular by default supports for path location strategy, but if we want to enable hash location strategy support, we can add use hash true while providing routes to the ng module. As we see here, while providing our routes, we can pass a second argument as object which contains the use hash property, and we can pass the value for that use hash property is a true. So this way we can enable the hash location strategy in Angular application. So the next is the routing events. Angular raises several events while navigating from one route to another route. We as a developer can subscribe to the router events and listen for a specific event and can perform action during the navigation. So these are some examples of routing events. So navigation start, navigation end, navigation error, navigation cancel, and so on. Actually there are 15 plus events in an Angular routing event. So here we have subscribed the router events and we are performing action on navigation end event. As we see here, we have subscribed to the router events using the router service, and we are checking the if the current instance is of navigation end event, so we will perform some action if the navigation end event occurs, as we see here. Okay, so the next is observables versus promises. So the observables emits multiple values over the period of time, but in case of promises, promise emits single value by resolving or rejecting it. Observables are lazy by default. They won't be called until we subscribe them using subscribe method. In case of promises, promises are not lazy, they get calls as we execute them. Then we can cancel observables using unsubscribe method, but in case of promise that's not possible to cancel the promises. We can use different types of operators while subscribing to observables, but there are no operators in promises. Okay, so the next is why to use TypeScript. TypeScript always points out the compilation error at the time of development, and because of this, getting runtime errors is less likely in a TypeScript. So the TypeScript supports static and strong typings. This means that type correctness can be checked at compile time, which is not available in JavaScript. Also, TypeScript supports interfaces, but JavaScript doesn't support interfaces. That's why we should use TypeScript over the JavaScript. Well, the next is why Angular team selected TypeScript over Dart. So the Angular team wanted the language which is aligned to JavaScript for writing Angular framework. So most of the web frameworks uses JavaScript. Also, most of the web developers uses JavaScript, That's why they wanted the aligned language for JavaScript while developing the Angular framework. So they choose TypeScript because TypeScript is a superset of JavaScript. So for developers, it is easy to switch to the TypeScript than the Dart. So there are lots of libraries developed in JavaScript. These can be easily integrated with TypeScript also, but it could be complex to integrate with the Dart. Also, as we know, TypeScript is a superset of JavaScript. We can just rename the file to .ts and it would be totally fine in TypeScript. Okay, so the next is change target of transpiling. To change the target of transpiling, we can make a change in a tsconfig.json file. There is one target property in a compiler options, and the default value is es next. We can change that value to allowed values of es3, es5, es6 slash es 2015, or es 2016, es 2017, and so on. So this will change the target of transfiling version. So the next is improve performance of an Angular application. A few popular methods or techniques help us to optimize the Angular application better. So here are some popular methods as we can see. We'll go one by one. Using the AOT compilation everywhere. Uh, Instead of using default change detection strategy, we should use on push change detection strategy. We should use the pure pipes. Always unsubscribe from observable once we have done the usage of that observable. We should use the lazy loading for feature modules. We should use the track by option for loop in a template. We should avoid computation in a template files. Usage of web workers will help to reduce the load on our Angular application. So the next is how to secure the Angular application. There are some methods to secure our Angular application. So the first is prevent an application from cross-site scripting. So in this way, we should avoid the user input bind to the inner HTML property in Angular application. Also, always use DOM sanitizer APIs to sanitize the values before binding to the Angular application. And use route guards when required, implementing content security policy, and do not use DOM's APIs directly. Prevent cross-site request forgery, prevent cross-site script inclusion. Always use up-to-date Angular libraries. Uh, don't modify the Angular copy. Use offline template compilers. Validate user submitted data on server side code also, and do not use components with known vulnerabilities.